Good morning.
Good morning. Ciao, Pete. Ciao, everybody.
Yes, hello everyone out there. Welcome to another episode of Edge AI Talks. And we're continuing through the summer. Hope everyone's had a good summer break or is on summer break. Or if you haven't taken your summer break, I think there's another week or so left. But
I am back in the office, Pete.
You're already back in the office. Yeah, I'm actually in Massachusetts for another couple of weeks. So that I'm pushing it all the way into September and then I'm back. But yeah, no, it's been a good summer as usual. Lots of cool things happening, and AI does not rest for the summer. So new things every day. I had a couple of public service announcements before we bring on our guest, Ashutosh from Intel. A couple of things. One is we are going to be at the Things Conference in September 23rd, 24th in Amsterdam. If folks are in the area there, I encourage you to join that event. It's traditionally been about low power kind of IoT and low power wireless, but this year it's expanding. The Edge AI Foundation will be there. We'll have a number of talks. We'll have, I think, about 15 partners there showing off kind of the latest and greatest in Edge AI. So check out the Things Conference, September. If you're in Japan and are part of kind of the Edge AI community, we are doing a kind of an academic symposium there in October. We can, I don't know if it's on our website yet, but we'll put it up there shortly. The other big thing that we just went live yesterday on registration is for our Taipei 2025 event, which will be November 11th and 12th in Taipei, in Taiwan. And that's going to be a great event, twice as big as last year. Tons of great keynote speakers from NTU, NTCU, two of the biggest tech universities there, as well as SIVA and Intel. We're going to have a panel from Hank Lee from Advantech. We're going to have a fireside chat with Dell. We're going to have lots of cool demos and workshops and all the usual cool stuff that happens at our events. If you haven't been to one of our events yet and are in the Asia Pacific region and have permission to travel and budget, then please go there and register. You can get to it on our website and stuff. So those are PSAs. Anything top of mind, Danilo, for you before we get into it?
As I'm chairing the generative AI at the Edge Working Group, so stay tuned with that because the fourth forum will be organized and will take place end of November. So stay tuned for more information and get involved with the foundation because generative AI at the Edge is a super cool thing.
Yeah, it is, and agentic AI is part of that too. I think I was reading a paper the other day about agentic AI and giving some feedback about. One of the things on agentic is around connecting it to the real world. Like, what's the last mile question about how agents interact with the real world, and how does that affect Edge AI deployments and stuff. So I think that's going to be a hot space. And interestingly, like we have Ashutosh Kumar from Intel. I'm going to introduce him in a minute, but Intel joined the foundation recently as a strategic partner, and it was really kind of a milestone because as we talk about Edge AI. As Danilo, as we started in the TinyML space and we've sort of evolved to this kind of bigger conversation, Intel represents, a part of that bigger conversation as well. So I think we'll hear a lot about that today. And so to that end, why don't we bring on Ashutosh? And let me give him the big spot here. There you go.
Good morning. Good afternoon.
Welcome.
Welcome.
Thank you.
Are you in California right now?
Yes, I am. I am in California, working from home today, but we'll go to office in a little bit.
Office. That sounds good. Cool. Yeah, I was just telling Danilo, having Intel as part of our community now is kind of an interesting milestone. As we've evolved that conversation to this broader Edge AI conversation, inclusive of a lot of the ultra kind of edge things that we've been talking about. So we're excited today to learn more about what Intel's been up to in this space. And I mean, as many people know, Intel deployments are pretty much everywhere. And so when you talk about efficient edge AI, Intel's pretty much always at the center of the conversation. So I think you guys have been doing a lot of work to kind of bring developers along into that space, take advantage of all these deployments. Right?
Yeah, I mean, it's been about 7 years. Like Intel has been serving the edge for many decades, from embedded spaces to now actually providing a lot of AI compute. Primarily Intel is known for the client computing and the data center workstations, but we have been serving the edge workloads for decades, from industrial to retail to healthcare. There are so many different unique workloads that require different kind of compute. I mean, sensors are at the far end side of the edge, but then when you bring in like where you need more compute power to run like data processing workloads and trying to make sense of all the sensor data, including cameras and different like pressure sensors, temperature sensors, running your payment workloads and at retail point of sale scenarios. Intel is like prevalent in a lot of those edge AI workloads.
Definitely. Cool. But Daniel, you're going to say something?
Yeah, just a very short comment. Ashutosh, having Intel among us in the sense between the members, the partners of the AGI Foundation is super great. Really, when I saw Intel, when Pete said Intel is joining, wow, that's great. So really, I'm super motivated to see Intel and the contributions. And obviously also in the generative edge AI space. So very good.
Yeah, we are excited to be a part of the Edge AI Foundation as well. There are so many amazing industry partners. We are driving this initiative together. So that's definitely a lot to learn from each other. Right.
Cool. Hey, I just want to also remind viewers that this is a live stream. So there's Q&A. If you're on YouTube or LinkedIn or StreamYard or Twitch, you can post your questions here in the stream, and we'll post them up here and get to them. So feel free to do that. Usually it takes one person to ask a question, and then everyone else joins in. So that's fine. So let's see, Ashutosh, I know you have a brief presentation. Do you want to jump into that? And that'll probably spur a bunch of questions. And
especially I want to talk a little bit about our Open Edge platform initiative. So just about a few months ago, Intel has been a big proponent of open source. Linux, one of the biggest operating system, right? Like, so Intel was at the forefront of driving Linux, right? Like, and for the edge, we have been doing a lot of different stuff and a lot of different open source software projects for past few years. OpenVINO is one of the very big example. It came out in about 7 years ago, but now it powers so many of the AI workloads that runs on your PC and the edge on Intel compute. So to expand into all these efforts, about 3-4 months ago, we brought together a comprehensive software stack initiative under Open Edge platform. It's 40 or 50 repositories and with different curated work like libraries and components and sample applications and more than 8 million lines of code, all available on GitHub for free, royalty free. Mostly under Apache 2 licenses, so developers can build on top of it. So I'm gonna go into a little bit of like introduction of like why we are doing this, and then maybe show a quick demo of one of the sample applications that we have in the Open Edge platform repo as well. So
awesome.
Let me know when it's good to get started.
Go for it. I'll throw your screen up there.
All right, let me start sharing.
I put a link to your OpenEdge stuff on the web there. Okay, let me bring this up. So yeah, why don't you get into it? I think Danilo and I will hang back, monitor the questions, and then we'll jump in at some point here once we get a few good ones.
Yeah, sounds good.
Good.
Yeah.
Cool. All right.
Okay, so as we have been working in the edge, we know some of the key challenges that we face, right? Like there is use case fragmentation, and then and that requires like a very heterogeneous type of compute, varying power and performance needs. There is also legacy infrastructure and operational complexity that you need to support. You cannot just go into each digital transformation, just go and rip and replace your infrastructure. As it has to be able to support those price sensitive, low power, different space constraint environments, the legacy infrastructure that you have in those complex operational scenarios. And it's not that like your AI workload is going to run on its own. There is always an existing workload. So you have to be able to support on top of that existing compute, existing workload. There is concurrency, kind of real challenge at the edge as well. So to enable these heterogeneous and challenging like AI at these in these constrained environments, you need a range of like performance, efficiency, range of flexibility to be able to scale in your distributed edge locations. There is a driver's hardware stack needed that needs to be fit for specific use case purpose. You need to be able to ensure that like it can support the type of workloads that you need to deploy and run in those use cases. And because there is this diverse ecosystem, there is always a lot of proprietary stuff, proprietary source code, proprietary developer tools. How do we make sure that like it is developer friendly? They don't need to go and learn a lot of things, but they need to they are easy to integrate into their development workflow. So this is the philosophy behind OpenEdge platform, that we are bringing together modular and optimized Edge AI libraries, a manageability software that allows you to manage your infrastructure and workloads in your distributed environment, and also a microvisor toolkit that allows you to create composable like base OS. It's not for production deployment, but whenever we come with new Intel hardware, there are a lot of new features and capabilities that come out, and we develop kernels, Linux kernels for those new features and capabilities. Edge Microvisor Toolkit is the first thing to port all those kernels capabilities, so you can quickly test all those on the newest Intel hardware until your favorite OS distributor actually integrates those for production deployment. And for AI and software application developers, the AI libraries contain a lot of key components and toolkits and libraries and microservices that you can use to speed up some of the application development workflows. For example, I mentioned about OpenVINO. OpenVINO is our inference optimization framework, where you can train your model in any of the popular frameworks, TensorFlow, PyTorch, PaddlePaddle. Use OpenVINO to optimize and quantize depending on your targeted hardware for deployment, and deploy just by writing simple one code to be able to deploy on CPU, GPU, NPU, all Intel hardware using OpenVINO. We also have Getty. Getty is a computer vision model training software. So you have custom data. In most of the enterprise use cases, models trained on internet, data available on internet don't work. So you often have to, especially let's say computer vision use case. Getty is for computer vision primarily. For your custom data that is not available in the open internet, you need to fine-tune the model architectures on your custom data, and then have the trained model optimized and then deploy in your application. So Getty provides you that kind of capability. It's all free. Scenescape is a spatial intelligence capability that can give you multimodal information from not just cameras, but many types of sensors that you may have in your environment, and bring in a digital twin of your space where you can understand and monitor your spaces with, let's say, for workload safety, for other safety and security use cases, for intrusion detection, those kind of use cases, for intersection monitoring, for traffic, and many more. And our OpenEdge platform, GitHub, actually has some of those sample applications that take advantage of these capabilities. And then Edge AI Suites is basically industry-specific curated set of these components and benchmarks and blueprints where you can get started with application development for those industry-specific use cases. This is how I just wanted to show this. We call it a architecture slide, but this is more about how it interplays with different pieces within the Intel's partner ecosystem. Of course, foundation is Intel Silicon, and then we have like all the infrastructure software. We provide some infrastructure software to get you started quickly, and then we work with those are composable ingredients that you can mix and bring with your infrastructure software of choice, be it Kubernetes, be it Docker, and any OS or other software that you want to deploy your application on. And then you have the AI libraries, the composable, and depending on like what you need to use for your application development, there are also pre-built microservices in the AI libraries that you can directly connect into your application development using APIs. That's so that you don't have to build those yourselves. And Edge AI Suites, as I mentioned, some sample applications and benchmarks that help you understand what kind of hardware systems do you need for deploying performant AI applications for your use cases, for your industry use cases. I want to just go a little bit into AI Suites. There are 4 AI Suites available currently. There is also more coming, and just actually let me go a little bit in the next slide where I want to talk more about like what do we mean by benchmarking and sizing guides? What do we mean by sample applications? So in a lot of cases, like different, as I was mentioning in the beginning as well, different use cases for your industry, for your Edge AI use cases, they may require different performance. Like if you have 5 cameras to support versus 50 cameras to support, you need to identify the right resources that you need to set up in your environment to run those desired AI workloads performantly and meeting the business needs that you have. So those are the sizing guides and benchmarks that help you understand, hey, if I deploy on this particular Core Ultra workstation, I will be able to support probably 30 camera streams. So those kind of things that help you with benchmarking and sizing guides. And then sample applications are just like sample applications for specific use cases that you can use to assess your workflows and figure out, if I want to run a self-checkout workload, computer vision powered self-checkout, can I run it on a Atom machine or can I run it in a Core Ultra machine? So those kind of things that you can utilize sample applications to assess. Similarly, software development kits basically bring together a few of the components that you would need to build, let's say, your video analytics or your generative AI applications. And we also work with our partner ecosystem. We have like 4,000 partner ecosystem that we work with at the edge, and to verify and create some blueprints of AI edge systems that you can directly, that customers can directly get from those partners and deploy for their use cases. So just I've already went through some of these key pieces. Just want to highlight briefly that the retail AI suite that you will see on our GitHub, it brings together some of the key sample applications like automated self-checkout, loss prevention, order accuracy identification. And then these are some of the library components like Deep Learning Streamer. Deep Learning Streamer is an optimized media analytics pipeline that builds on GStreamer. You can bring in audio, video data to build your media analytics pipeline. And then there is also DLStreamer pipeline server. So it's built on the DLStreamer framework, but it is a microservice. So you can directly integrate into your application. And I will show an application demo that actually utilizes this DLStreamer pipeline server. OpenVINO is our inference optimization framework that powers most of the AI acceleration on Intel hardware today at the edge and in client PCs. And Getty, I earlier mentioned about as well, Scenescape also for computer vision model development, Getty, and Scenescape for building your spatial digital twin. Similarly, for smart cities and safety and security use cases, there are smart network recorder sample applications, smart intersections, smart parking, lighting detection, sensor fusion for traffic management, some of the common libraries that the Metro AI suite also utilizes. Similarly, for manufacturing, there are many different use cases, sample applications that are available in our GitHub as well. And the AI libraries are those common application ingredients that I was mentioning earlier about. So I'm just going to briefly show a few of those. So OpenVINO, I mentioned, like you can bring any models in any framework and then optimize with OpenVINO and deploy on any of the hardware. You just write one core and then you can just use targeted device. You don't have to custom like recompile for each of the different devices. OpenVINO does that for you. Getty, I mentioned as earlier as well, it supports object detection, classification, segmentation, task chaining type of workloads. It also has some of the vision transformer architectures that you can customize for your use cases. And it also utilizes things like segment anything model that was released by Meta a couple of years ago. Sorry, did I lose?
I think you might have lost your desktop somewhere in the mix.
Yeah, that looks like my share screen.
Your share screen is unshared.
Sorry about that.
This is reinforcing our live part of our live stream.
PowerPoint tree. PowerPoint tree started.
Yikes. Where's Microsoft when you need them? Hey, here's a quick question from Carl while we're redoing stuff. I remember Carl from when I worked at Microsoft. So Carl, thanks for tuning in. He just noted that he had first experienced Edge AI with OpenVINO on the good old Azure Percept platform, which is actually a platform I worked on. Up and running very fast. And then, yes, we discontinued it. Microsoft did, not me. NVIDIA DeepStream. So I guess this is an interesting point. there's NVIDIA DeepStream, which there's a lot of people in that environment, and CUDA and that
Mhm.
software environment. And would you say that this OpenEdge platform is, an alternative to that? Is it a simpler platform? Is it a platform for more kind of brownfield deployments? I mean, how would you compare and contrast the NVIDIA environment and the OpenEdge environment?
Yeah, so DeepStream is one component. If you look from like
Right.
NVIDIA's
video.
Edge stack, you're right. Like so for media analytics. So the deal that also builds on GStreamer, optimized for NVIDIA environment.
Mhm.
So similar to that, like we have DL Streamer, which is optimized for Intel environments, and that also builds on GStreamer, and you can basically utilize that to like build those media analytics pipelines that can run on any of the Intel hardware.
Okay.
OpenEdge platform actually brings together more than just the streaming analytics capabilities, right? Like so, if you would look at, I mean, NVIDIA also has like, if you would look at their AI enterprise stack, there are a lot of things in that AI enterprise stack
Mhm.
that can serve different needs, different developer needs, depending on what level of entire application development and deployment stack you are working on, right? Like so,
Right.
if you want to directly use their NIMs, you can go and use their inference microservices for specific use cases or specific blueprints.
Right.
We provide some of those sample applications from the similar intent where you can actually utilize those sample applications, but we don't intend you to use those sample applications directly in your deployment. Because these are sample applications, right? Like, so your
Sure.
deployment needs would vary, but it
Sure.
gives you that architectural understanding of like how you can actually build that optimized workload or adjust your application to include some of the optimized components rather than completely re-architecting your application. And just bring in some of the optimized components and then speed up your development pipeline.
I see. Okay. So in terms of like, when should someone decide to use like the NVIDIA environment versus the OpenEdge? Is it really like I'm going to be deploying across a wide variety of kind of CPUs and GPUs, and OpenEdge has that advantage, or I'm all in on Jetson, whatever, and so I might as well stick to NVIDIA? I mean, what kind of decision making?
Yeah, so what we experience is in a lot of cases, right? Like people start with NVIDIA because everybody knows about it, and then
Sure.
and then you start building on NVIDIA, and then you figure out, oh, there are other challenges for Edge for different workloads, right? Jetson may not be suited for all of the different heterogeneous use cases that you would encounter at the edge, right? You have power requirements, you have performance requirements, you have cost requirements for your business. How do you identify different like criteria that you need to build your application within that criteria, and it has to be performant now, performant depending on your business KPIs, right? So in a lot of cases, right, GPUs, I mean, edge AI workloads, you typically don't want to add discrete GPUs because those are like generally 150 watt that can be pushing your power envelope, and GPUs are also not known to be that stable in those kind of ruggedized environment needs, right? Like so, those become another challenge.
Right.
And then you have these legacy infrastructure as well that's that you need to be able to migrate from there, but be able to not go completely off board where you have to completely redesign your factory environment itself.
Right.
So
yeah,
so that becomes very business KPI driven. where you want to deploy these kind of CPU, GPU, or different hardwares that you need. And the bigger advantage, I would say, especially for edge workloads, is the GPU capability with integrated GPUs and integrated NPU in our Core Ultra processors. That gives you that kind of compute on top of the kind of media analytics workloads, media encoding, decoding that you need for a lot of these workloads, right? And integrated GPUs also enable you to, as Danilo was mentioning, right, like the generative AI at the edge. You're not gonna, like, most of the generative AI at the edge is few tens, like less than sub 10 billion parameter models, right?
Right.
Not more than that.
Right.
So these like integrated GPUs and NPUs and these accelerators give you enough compute power to run those workloads pretty performantly. And if you combine with OpenVINO optimizations, you can do even more.
Yeah. Well, it is a fact that as things get commercialized and deployed, as a software developer, you always want to be running on the latest platform, the latest chip, and whatever. But then, when the finance people get involved, they say, "Yeah, but we've already deployed this hardware, or there's certain cost targets we have to hit, certain power targets." So this is one of the interesting things about the edge is the edge. The gravitational pull of the edge tends to, put more of a focus on cost and power.
Yeah, and especially because it's so decentralized, right? Like in the centralized environment, you can like create that kind of efficient setup for your for all your compute needs.
Yeah.
With decentralized environments, you get a lot of benefits by decentralizing specific heterogeneous compute for specific target workloads, right?
Yeah, for sure.
At traffic intersection, you don't want to put like $5,000 device there.
Yeah, that would be a little pricey. No, you're right. Oh, go ahead, Danilo. You had.
Yeah, thanks, Pete. For me, it's a unique opportunity to pose some questions to Ashutosh. So, at least from an external point of view, external to Intel. I mean, Intel is huge. Has been huge for all the time since its inception. It does silicon nodes. It does hardware IPs, hardware components. You mentioned CPUs, GPUs, NPU, FPGAs. So really heterogeneous. And then these are assembled in system on chip for various applications and in the industry domains. And there are also disruptive compute models which are on the table. I mean, in memory compute, analog, digital, whatever, and neuromorphing. Who knows what else can be devised? So, I mean, Intel has it's well posed to have a privileged view on all these things. So, coming to the question, how the suite manage all these heterogeneous components? What are the principles that me as a developer of AI at the edge can work in a relaxed way with the suites, having all of these components, hardware and so on, I said, behind the curtain?
Yeah, that definitely becomes a challenging environment, like when you have to like curate applications for specific targeted devices and all. So OpenVINO, of course, is one of our foundation inference deployment engine that kind of takes away that complexity from developers' minds, that you don't have to worry about what your end deployment will be. You build your model, optimize with OpenVINO, and quantize with OpenVINO, and then when you're writing the code, you can have when you're writing that deployment, you can have it targeted, and that, okay, I want to deploy this model only on the iGPU or any of the GPU form factors. Right. So you can select that device and make sure that like it gets deployed on the GPU only, or you can let OpenVINO pick one of the targeted hardware resource available with auto configuration, and then deploy accordingly there. So that way, the model deployment becomes more streamlined with OpenVINO. For most of the like suites and libraries, we do make sure that like this kind of capability come in to those libraries that will be important for developers. So for example, we were talking about media analytics, right? Like, so the deep learning streamer framework and microservice that we have, it basically, of course, builds on GStreamer, but brings in OpenVINO inferencing capabilities. So as you optimized OpenVINO models, you can just put it there, and then your media inferencing, media analytics pipeline, you can just build using that. So that way you can easily integrate into your media analytics workload. Generative AI workloads, right? Like, so OpenVINO gives you a lot of these latest optimization techniques, right? Like for pruning, for KV cache optimization, and quantization into int8, int4, all those things that you can utilize OpenVINO to quantize your generative AI models for deployment on specific hardware. You can target them depending on which models you are utilizing. You can target them onto the neural processing unit for ultra low power compute, and then you can also target them on the integrated GPU or discrete GPU, depending on what your deployment environment is. But the whole point of like bringing these system on a chip together is that like enabling our like hardware and developer ecosystem, that like you don't have to worry about multiple different accelerators. You can use one Core Ultra processor, different levels of Core Ultra processor with different compute requirements, different compute capabilities, different like SKU ranges, different power envelope ranges. You can deploy for different use cases. So for example, like the latest generation of Core Ultra PCs or Core Ultra Edge devices that so PCs were called Lunar Lake as intern, like kind of a code name, and it was like a Core Ultra Series 2 processor. You can get close to 100 TOPS on that single SoC of AI compute. And similarly, the Arrow Lake, that's the desktop version of that Intel Core Ultra Series 2 processor. Similar 100 TOPS capability, as well as like all these media optimized encoding, decoding capabilities, so that you can run your media analytics workloads very performantly on a single SoC.
Wow, impressive. Hey, before you jump back into your presentation, we had another question from Chris that I thought was kind of a bit existential around balancing kind of open horizontal platforms versus vertical walled garden types of environments. And where do you see sort of the Open Edge initiative sort of landing in that context?
Yeah, I mean, at Intel, we definitely, because we work with such a vast ecosystem, we believe very heavily in open ecosystem. And that's definitely our main mantra behind Open Edge platform as well, to enable wide range of open ecosystem where our developers have that choice to bring things that serve the needs for their business business KPI for their application. It's, I mean, as Chris is mentioning, one API versus CUDA. So there are a lot of hugely super optimized different level of AI library, different level of libraries that are a part of one API tool suite, right? Like, so you have one DNN that's primarily targeted for your deep learning neural net optimizations. And then you have other analytics libraries that you can utilize into, let's say, scikit optimization, right? Like, so similarly, CUDA also provides you CUDA optimized scikit libraries, or I think it's called Rapids or something, QRapids or something. And then you have cuDNN that powers most of the deep learning workloads. But with one API, of course, it becomes more useful for broader community, broader systems community as well to take advantage of that kind of optimization and build on top of them for their architecture.
And one API works with ARM processors as well as x86, right?
I think so. I'm not 100% sure, but I know that similar capabilities have been developed by AMD as well, right? Like, so
sure,
it kind of parallel to one API initiative.
Yeah, I think there was the one DNN initiative and some other things that were designed to support ARM processors within that environment. Because like you said, there's a heterogeneous environment where, maybe there's a gateway here, but there's other things also hanging off that, other things that need to be managed. So, but no, that's a good point about kind of these kind of open platforms as opposed to walled gardens, because I think that can be a trap that some folks fall into, where it seems like the most expeditious route is to sort of stay inside the country club for your solution.
Yeah, in a lot of cases, that's the scenario as well. That because I mean, work we have to do within the edge AI ecosystem is that there is a lot more education for the customers needed. That, hey, there is it's not that there is only one choice you have, right? Like, so there are so many optimized workloads that will fit much better for your needs.
Yeah, definitely. Cool. Go ahead, Dean.
Maybe one question before Ashutosh restart the presentation. It's clear, Ashutosh, the focus on you said many times about open source, right? And I was wondering what's your position about in the context of open source about benchmarking and free model zoo. People really would like to get objective measurements of performances, and would sometime about the model zoo would like to be free from licenses, royalties, especially the small, medium enterprises are looking to that. What's your opinion, your take on that?
Yeah, I think that's a very good point, because I mean, when you are comparing model performances on different hardware, you want to be objective about whether it will actually support 30 streams per system that I need, or at the cost that is beneficial for my business, or is it going to be that I have to tailor for this particular use case, and then if I want to use that same model for a different environment, I have to go and redo everything because this doesn't serve that kind of environment. So yes, model zoos definitely help with that kind of more balanced view of where you can actually test the performance right out of the box. And we at Intel also we do provide a lot of those models, pre-optimized models on Model Zoo. in a lot of cases, we cannot distribute some of the things, right? Like, for example, if you go to YOLO series of models, the recent models have been like mostly licensed. You cannot just distribute optimized version. People have to basically download their own version and optimize them. But within our model zoo as well, we have a lot of open source models that are like optimized and easily available for developers to try and test it out. We do provide some of the performance benchmarks that we have computed and how we have computed, so that you have a fair idea of like, okay, this is how these performance benchmarks were computed. That you don't like if there was a specific optimization that you are like your business application like requirement doesn't restrict you to use that kind of specific workflows. How do you adjust and then see what will be your true performance for your workload, right?
Cool. So we want to give you time, Ashutosh, to get back over to your presentation that was rudely interrupted by PowerPoint crashing. So why don't we'll step back. I will.
Yeah, it's kind of interesting. This had never happened, a PowerPoint crash. So I do like I
just want to note to folks they can still ask more questions
earlier.
And we'll have some time at the end, but Danilo and I will hang back a little bit and you can catch up. And I think you said you had a demo.
So I do want to go into a demo and show.
Yeah, sure, go for it.
Yeah, so I'm just gonna like quickly wrap up the slide and go into the demo actually. So I was talking about OpenVINO and then Getty, and then there is the DL streamer, deep learning streamer that we discussed, right? Like, so you have the encoding, decoding pipeline, and then you bring in all these inferencing capabilities, and those are optimized with OpenVINO, and basically deploy your application. Build your video analytics application pipeline. And this is the microservice that I was talking about that gives you a REST API interface of the deep learning streamer pipeline. And you can just directly integrate into your media analytics application. Then the Scenescape capability that gives you more of a spatial intelligence digital twin, bringing multimodal sensor data analysis capability together to build a digital twin of your environment. We also have a time series analytics microservice that allows you to use some of our OneAPI accelerated scikit libraries to run traditional machine learning workloads on sensor data, time series data, that you can directly integrate into your application as well. And for generative AI as well, we provide some of the reference architectures. So for example, for chat Q&A, there are a couple of different architectures that are provided within the Edge AI libraries. One is basically a monolithic application that you can deploy as a Docker container itself, but the other version is more of a scalable application. Both utilize retrieval augmented generation pipeline so that you can bring in your custom data within your environment to build that kind of chat Q&A workload. And some of the infrastructure software I just briefly want to highlight. So Edge Microvisor Toolkit I mentioned earlier, it gives you that minimal Linux environment to test out all the Intel Silicon features, because it brings in all the kernel optimizations, security capabilities, and AI runtime directly into an immutable image. So you can reliably and repeatably test that application performance on in your deployment environment. I'm gonna skip these. Oops. Again, looks like PowerPoint might crash again. Okay, I'm gonna actually skip the presentation part and go into a quick demo. Okay, there you go. Shows up now. So I have a small 4x4 NUC where I'm basically deploying one of the applications. So I am going to go here. So this is Edge AI Suites GitHub, right? So I like if I go in here, and we have different AI suites here, and I'm going to show you one of the sample applications from here. So manufacturing AI suite has few different sample applications. There is a human-machine interface sample application example. There is a Winterbrand anomaly detection using time series data use case, and then there is a computer vision type of different use case environment, which you can customize. This uses the DL Streamer pipeline server microservice that I was talking about, and it also supports models that you build using Getty that gets optimized with OpenVINO, so you can basically deploy directly in your application environment. So let me. So I'm going to just show you an architecture of this particular application, right? Like so, these are some of the components that we provide as a part of the AI libraries as well. And then, of course, there are open source components, right? Like you have the Media MTX server, you have OpenTelemetry collector, and you start your pipeline, and then you have like video stream images coming in, and it starts building, and it starts showing you all the like different types of workload that you want to customize it for. So I'm gonna show like if I go into further down here, so you can see it supports. Currently, it is supporting like 4 different pipelines. You have a worker safety gear type of use case, or weld porosity detection. So these are different sample applications. You can of course customize it based on your use case or demo that you are trying to build. And setting up is super straightforward. Actually, here if I go into the palette defect detection, so you just clone this and activate the environment. Of course, you can customize the environments. There are some variables that you need to provide. I'm going to show you a little bit like how I have put some of these like variables, and then you just run setup.sh and Docker Compose. So I already have run cloned the environment and set up this. So if I'm going to show you quickly here as well. So this basically sets up the environment variable and downloads the models needed for the application. And oops, let me actually show you the Docker Compose as well, so that you will know, you will get to see like what kind of services are getting deployed. So you see the DL Streamer pipeline server, and you can see the Media MTX and the Coturn that you were seeing in the application architecture as well. There's the model registry and Minio database, Prometheus for the UI as well. Grafana, basically we utilize Grafana for building your dashboard, and Docker Compose up -t. It's basically like I already have all the containers downloaded, so I don't have to spend time downloading all those things. So it sets up, and you can see some of these like sample start, etc. These help you understand like what kind of pipelines it's supporting right now. And once it is set up, I will show you how to see what pipelines are loaded. Okay, so this is set up. Let's see Docker PS. you can see all these services, container services are up and running. And I'm going to run simple list. You can see different like pipelines that are already loaded. So it's loaded currently, the pallet defect detection one. I'm going to start. Okay. Okay. Now it's ready, and you can see that it found the pipeline and started. So I'm gonna go back here. So you can of course customize this and it takes less than 10 minutes to basically test this application out. Of course, it depends on your internet connection as well, how long it takes to download all the containers. Now, this sample application actually gives like the containers that we have in our Docker repository. But let's say you customize your DL Streamer pipeline service, pipeline server microservice, and you want to use that specific container in deployment. You can, of course, change your Docker Compose file to use a specific version of that Docker, that microservice to build your deployment pipeline.
Cool.
Okay.
Excellent.
So that was a quick demo of the sample application. There are many.
Yeah, no, that's good. There was a question here from.
Sorry, you were saying something.
Yeah, the question from Amar asking about the NVIDIA Jetson equivalent. I don't know. We don't have really time to get into it, but suffice to say, you're showing some, pretty straightforward stuff that makes it easy for people to do this sort of thing. And, people have to think about what kind of ecosystem they want to get into and how open the platform is. So we do have a couple of minutes left. I just wanted to be cognizant of time. What are your sort
let me pick up an. So I don't know how many, most of the people have seen these 4x4 NUCs, right?
Yes, the famous NUC. Somehow. There you go.
This is better.
Box.
Right. So these are the ones I use for my dev kit, right? Like, these are less than like $400.
Yep, inexpensive. Excellent. What's the call to action here? How can people get more
and this comes with like. Yeah, try. There will be more dev kits like we are will be coming in later as well, and just try it out. Try the application, the AI libraries. Try the sample application. It's really straightforward to get started, at least with the sample application. Then you can learn about like what things you want to customize and how do you customize your architecture. So those things will be super easy to get started. There are a lot of like super complex application architectures available as well. As I mentioned, like Chat Q&A. If you just look at Chat Q&A architecture, it's actually like a production grade architecture, but you can of course customize it with your specific use cases.
Awesome. Well, Ashutosh, thank you so much today for giving us a little intro to OpenEdge. I'm sure there'll be more to follow. Danilo, any closing thoughts?
It was awesome, your presentation, Ashutosh, and it triggered more questions, maybe offline. Thank you so much.
There you go. Cool.
Thank you. And thank you for having me. It's always good to have a conversation and listen to the amazing talks that we have at AI Talks.
Sounds good. All right. Thank you. Thanks, everybody. Talk soon.
Bye.